So we're looking at lesson 7 today, from parallelograms to triangles. So let's go ahead and jump on in. It's a tale of two triangles. Two polygons are identical if they match up exactly when placed on top of one another. So scroll down. Draw one line, to decompose each of the following polygons into two identical triangles, if possible. Use a straight edge to draw your line. Now, obviously on here, I'm not going to be able to take and use a straight edge to draw my line. So my lines are going to be a little wonky, not straight. But we're going to do the best that we possibly can. Now, for you guys who are taking and doing this in your workbooks, by all means, get a straight edge ruler and take and draw these lines so that way they're nice and exact. So we want to take and decompose these using one line to get two identical triangles. So we want triangles. So with this square, we can't split it down the middle horizontally or vertically. But if we take and go from one corner to the other, and I know that line is far from straight, but if this were a nice straight line for us going through, these two triangles would be identical. The same holds true if we were to take, I'm going to draw another line. If we were to draw a line from here, maybe it's really wonky, to here. Once again, my lines are far from straight. I apologize for that. But we could have triangle here and here, or we can have a triangle here and here. It splits them into two identical triangles either way we do it. So it's based on the diagonal for this. Now for B, once again, we have to be careful because this one's very, we've got a parallelogram that's very slanted here. So to make sure that they're identical, we have to be super careful. So this-ish would be two identical triangles. So going from the vertices that are opposite each other. We can also have one that goes, well, if it were straighter, once again, remember, straight lines, not my crazy curvy ones that I'm drawing. But cutting it straight through the middle here, which does go from one vertex to another because of how this is lined up, will give us two identical triangles as well. Now, with this one over here, if we tried to go from here over to here, are those identical triangles? No, those aren't identical at all. What about if we try to go from here down to here? Are those going to be identical? Not in the slightest. So in this one, it's not possible. All right, for D, just like with our square, going from one corner to the other will produce two that are the same, and going from the other corner. Now, on this one, if we cut it, are those the same? No, they're not. This angle here is much bigger than this angle over here, so those are not the identical triangles. And the same would happen if we cut it this way. So it's not possible. All right, for this one here, if we go from one corner to the other, it works. Same as if we go diagonally here. Ooh, that's not where I tried to do that one. And then last but not least, G. My line is not going well for me because this one's really narrow. But diagonally, I know it's really terrible looking, but diagonally through there, that will give us two identical. Same with diagonally this way. This one's a little easier to draw and see, but it will give us two identical. So the only two that it didn't work for were C and E. Now, for number 2, which quadrilaterals can be decomposed into two identical triangles? So A can, B can, D, F, and G. These can all be decomposed into two identical triangles. So number 3, study the quadrilaterals that can, in fact, be decomposed into two identical triangles. What do you notice about them? Write a couple observations about what these quadrilaterals have in common. Well, what we should notice is that they have two pairs of parallel sides. So for number 3, I'm writing it up here. So I have a little more space. Two pairs parallel sides. They're all parallelograms. All parallelograms. The triangles are formed by drawing a diagonal connecting opposite vertices. So diagonal connecting opposite vertices makes triangles. Some triangles are right triangles, some are acute, some are obtuse. So we have all different kinds of triangles. So they aren't necessarily all the same kinds of triangles, even though it works in each and every one of these. And for some quadrilaterals, there's more than one way to do it. So we found different ways to take and split these to get equivalent triangles. And in most cases, we found 2 ways at least to take and do it. Sometimes some of our figures may only have 1 way instead of having 2. Okay? So these 2, E and C, are not parallelograms. So C is just a quadrilateral and E is a trapezoid. So that's why C and E did not work, because they were not parallelograms. So in order to take and split or decompose our figure into 2 triangles, it has to be a parallelogram. So a parallelogram is 2 triangles put together, and that's why base times height, we use the vertical height if we did half of it, and then there's 2 parts that are identical. That's how we get our base times height. So that's how it takes and works. All right, your keyword for this lesson is triangles. Triangles. If you guys have any questions, feel free to ask. Have a great day.